Hello friends, welcome to my channel Data Science for Beginners. This is my first video providing a brief introduction to the vast topic of data science. I will be adding more videos, so request you to please subscribe my channel so that you have access to the new upcoming videos. My name is Shadab. I am a commercial effectiveness consultant with 18 years of analytics experience. I have led and executed more than 100 projects addressing a broad range of sales and marketing challenges. The field of data science broadly encompasses these four professions, starting with data science proper, data engineering, data analytics, and business intelligence. Data science is an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from data in various forms, whether structured or unstructured. It involves collecting, cleaning, manipulating, and analyzing data to discover useful information, inform conclusions, and answer questions. Data engineering, on the other hand, is concerned with designing, construction, and maintenance of data systems. Data analytics, which has been there for quite some time, relates to describing the behavior of data through simple analysis and visualizations. Business intelligence, which has also been there for a long time, concerns itself with turning data into insights for better decision making. It involves collecting, transforming, reporting, and visualizing data to understand what's working and what's not, in order for business stakeholders to take informed decisions to improve business performance. Let us now talk about the key traits of each data profession. A data scientist is interested in why over how. He or she enjoys analyzing complex questions to derive insights from data, usually big data. A data engineer is interested in how over why. He or she prefers to design and build IT systems rather than to analyze data. Data analysts are interested in understanding the inner workings of a business. They enjoy using data insights to improve business. They use apps to analyze the data and are not into deep analysis. And they have a solid math foundation. Finally, a business intelligence person is interested in exploring data and asking questions. They have the ability to assess information objectively and identify any biases. They are meticulous in data handling, ensuring accuracy and consistency in reporting. When we come to the key tasks of data scientists, they uncover correlations and causations in business data to support business decision making. They generate predictive and prescriptive insights from data and visualize them. Data engineers design systems to collect, handle, and store big data sets. They design, build, and maintain modular and scalable platforms for data storage, processing, and movement. Data analysts generate descriptive data insights and uncover correlations in business data to support business decision making. Business intelligence personnel clean, manipulate, and report data. They create clear, compelling, and insightful charts and dashboards. In terms of competencies, data scientists usually have a degree in quantitative and or programming field, example Python, R, Julia, Go, SQL. Their previous experience could include BI reporting, data analysis, data-driven decision making. Data engineers have a degree in computer science or software engineering. They are programmers and are good in maths but don't use statistics much. They are good with programming languages such as Java, C++, Python. Their previous experience could be a database architect, an ETL developer, a database developer, or a security architect. Data analysts have a degree in quantitative or business. They deploy analytics technologies such as Alteryx, and their previous experience could be into sales or marketing. Finally, business intelligence personnel have a solid understanding of the specific industry and its key metrics. They have an understanding of data warehousing concepts. They use basic programming skills, particularly for automation, for example, SQL, Power BI, Tableau, ClickView. After having introduced you to data professions, let me talk about the 4 flavors of data science. Data science includes data analysis for sure, which involves discovering trends, patterns, and insights in data that describe real-life phenomena. It includes machine learning, which is the process of deploying computer power to identify trends and patterns in data in order to make predictions about the future. We will talk more about machine learning in the later part of this video. Artificial intelligence is a machine or application with the capacity to autonomously execute predictions it makes from the data. So basically, AI has 2 elements: prediction or predictive modeling from data science, and execution or autonomous response from engineering. And finally, deep learning. It is a predictive methodology which borrows its structure from the neural network structure of the brain and is particularly effective for big data. Now let's go deeper into what exactly is data science. This is the classical definition of data science in the form of a Venn diagram proposed by Drew Conway in 2010. Data science is at the confluence of programming skills, quantitative skills, and subject matter expertise. In short, we can rename the circles as code, quant, and context. The intersection of code and quant comprises machine learning, so it doesn't require much of the contextual knowledge, the idea of machines learning by themselves. The intersection of quant and context comprises traditional research or data analytics. It doesn't involve much of programming. The area of the intersection of coding and context is often called as the danger zone because individuals in this area may be missing a crucial piece of the data science puzzle: mathematical and statistical understanding. Nonetheless, this area can include techniques such as natural language processing, which don't require much of statistical interpretation. The importance of subject matter expertise can be summarized in the words of a Gartner research leader as follows: organizations already have people who know their own data better than mystical data scientists. This is a key. Internal people have already gained experience and the ability to model, research, and analyze. Learning Hadoop is easier than learning the company's business. Here is an important perspective on data science, ML, and AI. Data science relates to manually discovering trends, patterns, and insights in data that describe real-life phenomena, while machine learning concerns with making the computers do the same task. It would be possible only after a significant time has been spent understanding the context. AI, on the other extreme, includes not only the prediction part of ML but also involves electronic or mechanical processes to execute the prescriptive recommendations of ML. In terms of a Venn diagram, artificial intelligence is at the confluence of machine learning, software development, and robotics. Let's talk more about machine learning. Machine learning algorithms can be classified into three buckets. Supervised learning is about making predictions from labeled datasets. Example use cases of supervised machine learning include predicting customer churn, spam filtering, image classification. Unsupervised learning is about making predictions from unlabeled datasets. Example use cases of unsupervised machine learning include customer segmentation, market basket analysis, recommender systems. Reinforcement learning is a type of machine learning inspired by how animals learn through trial and error. It involves an agent interacting with an environment, taking actions, receiving rewards or penalties, and adapting its behavior based on these signals. Example use cases of reinforcement machine learning include robotics, traffic light control, energy grid management, algorithmic stock trading. This is a tabular representation of key differences between the three types of ML algorithms. I'll take a pause of 10 seconds here for you to have a look. There are more than 100 ML algorithms and more than 100 ML use cases. So it is important to understand ways to group them in order to decrease time to value by hastening the model selection process. When you understand the data and the outcome needed, you could easily and quickly identify the potential ML algorithms to apply. Besides the way of learning from the data, the ML algorithms could be classified based on their function they employ, as well as the use cases they address. This is another way of classifying and identifying ML algorithms relevant for a given situation. The additional dimension used here is whether we have continuous or categorical data. Do not worry about the algorithms mentioned here. We will talk about them in detail in later videos. There are hundreds, if not thousands, of machine learning use cases. These are some of the simple ones: sales forecasting, spam email detection, recommendation engines, insurance claim fraud detection, customer segmentation, hedge fund classification, image recognition. It is important to familiarize ourselves with the machine learning terminologies. When you hear a machine learning expert say feature, remember that he or she is referring to a variable, attribute, a field, or a column in a dataset. Similarly, an instance refers to an observation, data point, value, case, or a row in a dataset. Target refers to the predictant or the dependent variable, and data refers to the predictor or independent variables. A word on Python programming language. We shall be using Python in our data science journey. The reason being that it is a high-level interpretable coding language that is useful for a wide variety of applications. Another compelling reason to use Python is that it is one of the official programming languages of Google. There are a number of benefits of using Python. It is an easy to learn human readable programming language. It has an extensive array of well-supported data science libraries. It has the biggest user base amongst all data science languages. Besides data science, Python is also useful in data analytics and data engineering. It is useful in both professional and academic fields, is an open source programming language, and can be used for web, app, and game development. A quick analysis of Google Trends shows that over time, Python has taken over R as the most popular programming language for data science. And even for the related field of data engineering, Python has emerged as the most popular programming language amongst the professionals and enthusiasts. The main Python libraries that we will be using for advanced data analysis would include NumPy, SciPy, Pandas. For data visualization, we'll be using Matplotlib and Seaborn. And for machine learning, we'll be using scikit-learn, TensorFlow, and Keras. Thank you for watching this video.